Welcome to Homework Lib.
Hi, so for this question, essentially the only thing that we need to do is remembering that the force exerted by the bar, it is going to be equal to a mass times an acceleration, right? And for us, acceleration is the change of velocity with respect to time. So essentially what we want to know is the accelerations at different times, which are times equals 0, time equals 0.9, time equal 1.3, time equal 1.2, and finally for time equals 2.5. Okay, so in order to do this, what we're going to do is look at the slope at different points. First of all, let's localize the points that we're actually interested in. So at times equals 0, whoop, times 0, at time equals 0.9, we can see that at time equals 0.9 we have a maximum. So this means that my acceleration over here, it is going to be equal to 0. Thus, the force is going to be equal to 0. At time equals 0, we need to know the slope that we have here. At times 1.3 and 1.2, both are going to have the same slope. So the force on both of these points are going to be equal. And finally, at time 2.5, the slope is going to change a little bit, but we can do the calculation. Recall that the slope of a speed with respect to time graph, it is going to be our acceleration. So at time equals 0, the value for acceleration is 0.375 meters per second squared. On this section, the slope is going to be minus 0.56 meters per second squared. Of course, the way that I'm calculating this is that the slope is delta y minus delta x. So I'm just picking 2 points that I see somewhat clearly. But if you have software that gives you directly the values, you can use that. And for the final segment, the value for acceleration is going to be equal to minus 0.226. Sorry, minus 0.2666 meters per second squared. So finally, we just need to get the values for the forces. In the first case, this is going to be 0.375 meters per second squared times the mass of the subject, that is 59.2, giving us 22.2 newtons. Let's just verify that the sign makes sense. For example, when you're pulling down on the bar, then the force of the bar needs to be opposite, so means going up for you to go up, right? So the sign matches up correctly. So for 1.3 and 1.2, the forces are going to be the same because the acceleration is the same. So this is going to be 59.2 kilograms times my acceleration, in this case minus 0.56 meters per second squared, giving us minus 33.15. And finally, for times equal to 0.5, same thing, mass times acceleration, so 59.2 kilograms times minus 0.2666 meters per second squared, giving us 15.79 newtons. And that would be all. Thank you very much.